Hello everyone. Let's understand the concept of linked list. Now, linked list is collection of nodes which are stored in a non-contiguous memory locations. Okay, so nodes that are stored on non-contiguous memory locations. Okay, and what do you mean by these nodes, right? So we have to understand this. We are saying that it's a collection of nodes which are stored in a non-contiguous memory locations. So what is a node basically? So node is a memory location which has two fields. Okay, so it has basically two fields. What are those two fields? Data and address. Okay, so every node holds a two values. One is the data and other is the address. Okay, and the structure in C, let's say I want to define a structure for this node in C, or I want to create this node in C programming. So I will use a structure concept. So struct is a keyword followed by name of my node. So here I'm going to call my node as node only. So I'm writing node. If you want to say it's a node like this, or you can say my node like this, anything is fine. But to keep it simple, I'm writing it node followed by curly brackets. And then I need to define these two fields. So as I said that my node is going to have two fields, data and address. So first is a data. Now, which type of data you want to store in your node, whether it is an integer type or a float type, on that basis, you can define the type of the data. Let's say I want to store an integer number. So I'll say int, and the name of that variable, the field is data. So you can call it as data, you can call it as val, whatever is convenient to you. Okay, so I'm calling it as data. And the second field is, as I mentioned, it's an address. Now, why we need this address? Because if you read the concept of a linked list, it's a collection of nodes. And these collection of nodes, they're stored in non-contiguous memory locations. So every node is pointing to the other node. And that's why we need to hold the address of the other node. Because it's like a link, it's like a chain, right? So it's like, it looks like a chain. Okay, and to form that chain, we need this address, right? So if when I say address, address to point to next node, and such such pointer, because we're storing an address, so this becomes a pointer. So we call it as a pointer. So such pointer is called as self-referential pointer. Okay, so such pointer is called as a self-referential pointer. Why? Because it is pointing to a node which is of the same type. And that's why it's a self-referential pointer. So the second field is address. So what will be the type of that? Because when I say data, so data, I'm going to store of integer type. So this address will be of what type? So as I mentioned, that is going to point to the next node, which is of the same type. That's why I'm going to write its type, which is struct node itself, right? Because it is the type of node which it is pointing. So the type is struct node. And because it's a pointer, so I'll use an asterisk sign. And then I may call that field as next. I may call that field as address. I may call that field as um, mm, next address, whatever, right? So whatever thing you want to call it, I'm just calling, sometimes you might have seen it as a link. Okay, so you can call it as a link, you can call it as a next. Here this episode, I'm calling it as next because I'll keep in mind that next means it is pointing to the next node. So it's an address with semicolon and curly bracket closed. And here for every linked list, a very first mandatory pointer that is required, even if the linked list is not created, you will need a beginning pointer that points to the first node. Because we don't have a first node, that pointer will be null, but there will always be one pointer that points to the very first node of a linked list, and here we call it as a start node. Many times you might have heard about head. Okay, so you can call it as head, you can call it as start, whichever word looks convenient to you, you can write that. So I've written asterisk start. Now, initially, because in the beginning, you will not have any nodes in the linked list, so you can give a null address to this pointer. That means there is no address in the start, which means I don't have any nodes in my linked list. That means my linked list is empty as of now. Once I will start creating nodes, then I will connect these nodes to the linked list. And that is what we are going to see in the next one. Okay, so this is the information, the introduction of a linked list. Now, linked list looks something like this. So if I say collection of nodes, so just give me 2 minutes. So if I say collection of nodes, our linked list looks something like this. So, so it's, let's say, a collection of nodes. So this is the first node, then it is pointing to the next node. So this is the next node. Likewise, you can add as many nodes as possible, right? So there are different operations that we perform with the linked list. Now, what are those different operations that we perform with linked list? So operations with linked list are insertion, then we have deletion, and then we have traversing, searching, right? Counting, displaying. You can do whatever you want to do with the linked list, right? So you want to display the node, you want to insert the node, you want to traverse through the linked list, you want to search, count, you want to count the nodes, anything that you want to do. But majorly, anything that we have to do, it comes with the main task of traversing a list. Whatever you do, you need to perform traversing, right? So you're performing traversing. That is what makes any other operation workable here. So we need to understand the concept of traversing. Now, what do you mean by traversing in linked list? Traversing means, because as I mentioned that there is only one pointer that we know as a programmer, we don't know all the nodes here basically, because there can be many nodes. So what you do is we keep track of the very first node. Okay. And then as and when we are starting adding the nodes, we can traverse the entire list by traversing through these nodes. Okay. So let me give you one example. Right now, there is no node in the linked list. So the start pointer, which I have just created, this start pointer will have null address. Right now, it doesn't have anything. So it's a pointer, right? So it's holding some address. Right now, there is nothing in this, right? Because my list is empty. Now, let's say I want to insert. Now, here, when we say insert operation, there are different ways of inserting into the linked list. In this video, we will see first thing, that is insertion in the beginning and insertion at the end. That means given a linked list, you can insert the nodes in the beginning of the list or at the end of the list. Imagine an example of let's say I have number of cards in my hand. So when a new card comes, I can even either keep those cards, the new card. So let's say there is a stack of cards with me. So there are a number of cards with me. A new card comes, I can keep that new card on top, or I can keep that new card at the bottom, right? So these two are the options. Third option is I can place that card in somewhere in between, right? So these are the three ways of doing performing insertion, but we have to understand it in terms of linked list, right? So how do we do that? How do we insert a card in the beginning? How do we insert the card at the end or in between? So in this video, we will first discuss of in the start or in the beginning or at the end. So let's understand that concept first. And while doing that, we will be needing the concept of traversing also. So let's understand that. So initially, the start is not having anything. Now, whenever we have to create a node, we first uh, ask the compiler, ask our system to give us a node. So our system is going to give us a node, and because we have already mentioned the structure of our node, the compiler, the system is going to give you a node. Let's say this is the name of this node is node here, right? Or new node, or whatever name you are going to give. Let's say I call it as a new name node. Also, this has two fields. So first field is data part, and second field is next part, because I have given these two names to my node. Whatever name you are giving to your node, that you have to write it. Okay. So this is a node which has a data part and a next part. Now this has been created. I may have added the data into this part. Now, how do I add a data into this part? I have to access this field of this structure. So how do I access this field where I have to store 10? So it's a very simple concept in C. You write the name of the node. So I want to access this node whose name is node. arrow. Now, arrow is an accessing operator which accesses one of the fields of your node. So node arrow, which field I want to access? This first field. What is the name of that field? Data. So I'll say node arrow data is equal to 10. So here I'm adding that value into the first field, right? Next, here I want to add something. So if whatever, depending upon the scenario where you want to insert whether it is a first node or a last node, you can insert the respective value into this next field. So you will write node arrow next is equal to, let's say right now I want to insert null because there is no other node and this is the very first node. I may say that it's having null value. So here it is having null value. Okay, so this is a data creation. So this is a node creation. So I have just created a node right now by adding 10 and n into it. But I have still not created a linked list. Creation of linked list means you have to mention the start node that this is my very first node in the linked list. That means start should have it at its address. And how do we do that? So we have to update the start. Right now, start is having null. Right here, you see start was having null. So now what we are going to do, we are going to update start with the address of this. Now, what is the address? As a programmer, we don't know the address, but we know its name. So node is the name of that new node that we have created. So we'll say whatever address of this node that has to be stored in start. So whatever address of this node, it will get stored in this start. And that's why this start is pointing to this very first node. And this is how you created the very first node of your linked list. Okay. Now there are scenarios like if I want to insert a new node before 10 or after 10. That means I want to insert before in the beginning or after the linked list, right? So there are different scenarios of it. So let's first talk about insertion in the beginning. That means when I want to insert anything before this node. Again, the same process happens that I will ask my system to give me a memory location having a name node. Now this is gone. This has become a part of node, so it is not node now. It's just I mean, it is a node, a part of your linked list. Now I don't have to bother about its address and all because it is there with the start. Now, when I create a new node, again, I can call it as a node, right? Because I've given it a name as node. So I'll say node, okay? And then this is the data part, and this is the next part. Now here, again, if I want to store something, let's say I want to store number 4 here. And do I need to store n here? No. This is only in the beginning. When first node that you added, it is the very first node. So, sorry, I forgot to mention that part. If in every linked list, the last node always holds a null value. Okay. So now in this linked list, this is the only node that we have, and it is the first node and the last node. That's why I have written this node next value as null because it is assumed that it is the last node. But when I add this node is not a last node because this node is last node. So I don't have to write here null value. Now what will come in this part? So because this node will come before this node, that means this node has to point to this node, right? Because now this node will become the first node. So here I need to create a link from here to this node, right? But how do I get the address of this node? Because as I mentioned, once it is given to the linked list, only start knows its address. That means start has its address. That means while creating this node, you do it the same way. Node arrow data, you are going to add 4. You're not going to add node arrow next. Here you are going to write node arrow next, node arrow next. Here you're going to add the value start. Okay, so rather than writing null, even if you write start here if also not null because initially start was null. So when you say node arrow next start, the null value will come here. So even if you do not write null in the very first time, you write node arrow next is equals to start. The first time, this will take null value. Second time, it is going to take the start address. So what is the start address? Address of this link. So now it has got the address of this node. And now after that, we update the starts, which is start equals to node. So now when we say start equals to node, start will not point to this node now because we've updated the address so that start now points to the node. So here, this link updates to this node. So now you see this node has been added before this node. So this is the logic behind insertion. Now, if I want to write it in the pseudocode format, so let me just write it in the pseudocode format now. So how do we do it in the pseudocode format? So here you can just say that you have taken it from, now in pseudocode, we just write it if avail. Now here we are talking about avail is a heap which is memory that is available to the system, right? If this memory is only not available, so we are going to write overflow, right? Because we don't have memory only to assign for our step. And here after this, we're going to just exit. So we will have to find out, go to step exit. Later on, we will write the step number here because to exit, we need the last step. Okay, so this I'm going to keep as of now blank. Now, if this is not the case, so in step 2, if this is not the case, the avail is not null, which means there is still memory left. So I'm going to set a pointer. Let's say set node, or you can call it as a new node. Okay. So here I'm taking a node, new node. So instead of node, I'm calling it as new node now. So I'm going to take the node from this avail heap memory. Okay. And once this is done, now what I will do is, because we created a new node, also once you take a memory from this heap node, you can just keep other available memory locations for another iteration. So we are going to point our heap memory to the next heap available. Okay, so here we don't need to bother much about this. It's simple that if there is a memory available, that means it is not null, then we take one node from it and then we point to the next available node. So that in the next iteration, if we need more nodes, it is going to give us that. Okay, now we'll focus more on this new node. Now, once we create a node, what did I mention? That we have to, we have to we have to add the data into it. So I'll say new node and arrow operator we use to add the data. So new node arrow data, and I'm going to send a value to that. So let's say there is a variable val which has the data, and we're going to adding the data. Also new node, it's the next part of that node, which is new node arrow next. Here, either you can store null because if it is a first node, or you can directly store a start value because as I mentioned, initially start has null, so that null will go in its null part. Next time the start has some address that will go in its next part. So you can directly write start here. So new node arrow next is start, and the last thing that we write is we update the start. So start equals to new node now. So we have updated new node and then we exit. So if everything is fine or properly, then we'll get these values. Otherwise, we directly go to 7th step, which is an exit step. So this is, we are exiting. Okay. Now this is the code for insertion of node in the beginning. So beginning, the insertion in the beginning is little easy to understand because nothing much has to be done. We just have to update the start node. But before that, we have to update its link to the new node, right? So we are just updating its link to the new node and then updating the start node. So simple, these step number 2, 3, 4, 5, 6. These are the important steps to understand that how we can insert the node in the beginning. Okay. In the next video, I will explain you about insertion at the end. Now, when we perform insertion at the end, insertion works along with the traversing concept because we need to know what is the end of the linked list, because when I'm going to insert nodes, there will be multiple nodes in the linked list. So how do I get to that last node? That will be the second concept. So after this video, we will go through that concept. Thank you.